All right, good morning. Let's get started. We got a great topic for you guys today, hosted by Andy Starnes of Insight Training. If you're looking to add, replace, upgrade your thermal cameras, this is definitely the webinar for you. Andy and his team, they've got thousands and several thousands on top of several thousands of burn hours with all these cameras. These guys are really the leading experts in thermal imaging training, and who better to help you get some insight to how to evaluate cameras and make sure that you're making the right decision for yourself, your department, your loved ones. So with that, we'll turn it over to Andy.
Thank you, Brent. So appreciate you joining us today. This is a Criterion-based evaluation program that we developed back in 2017 out of one particular reason. We get the same question asked every single day. I probably send out 100 or so responses a week. Hey, we've got this camera, that camera, we're looking to upgrade, which one would you buy? And they're usually surprised by my response because it's a very long one saying, you need to learn about the cameras themselves and test them. Here's why. In 32 years of doing this and being involved in the fire service, I've learned that everybody else, whether it's turnout gear or everything else, they test stuff, they spec stuff. But for some reason, thermal imaging cameras have been left out of it. And as I've learned a lot in the last so many years of playing with thermal imaging cameras, I've learned I don't know what I don't know, and continue to study and learn and be around smart people like the people responsible to this at Seek Thermal. And through that process, we were able to develop the first collegiate-based program that is a certification through Western Kentucky University, peer-reviewed by Kentucky Thermal Institute, and sponsored by Seek Thermal. You scan that QR code, you can take an online course and get a certification in tactical firefighting thermology, the only one in the world. That's where I would recommend you begin your education. It's all online, 12 hours, knock it out. And it's affordable. That's what we want for you, is to provide affordable education. And we're thankful to Seek Thermal for making this free to everyone, because this program is something that I used to charge for, now I give away, but still I do offer the class. But this should help a lot of people in the respect that we want you to buy the equipment that you need based on what you test and what you see, not what the salesperson says, not what I say, not what the manufacturer say, because this is not a sales presentation. This is a performance-based program that shows you how to grade and evaluate cameras on the market. And anybody that knows me knows that I will tell them up front that I will tell you the top 3 cameras, and I've got them listed in here. But I want you to know you can test any camera with these criteria and make sure that they match up to your expectations, not mine. Because when you're buying a car or buying something big for your family, I'm pretty sure you check with your family or your spouse and you make sure you meet those expectations. So we want to do that for you today and give you the tools to make you what we would call intelligently aggressive, so that you can make better decisions for your department, for the citizen, and for your fellow firefighters. And there is a definite need for this evaluation criteria. And like I mentioned before, the fire service is very good about speccing everything else. But for some reason, thermal imaging cameras get relegated to the end. I usually get a phone call saying, hey, we got X amount of money to spend and we got to buy it in a week. Which one would you buy? And I'm like, I'm not telling you. They're like, why? I was like, because you're not going to get mad at me. You need to do your homework. Well, I only got 7 days. I said, well, it's not my emergency. So I would recommend that you do your homework. And this is a great way of doing that. We're going to give you the structured format on how to do that. And these are performance metrics based on something called NFPA 1801. If you're not familiar with it, get on nfpa.org and you can read it for free. And it'll give you the ability to pick your top 3 cameras and test them. Small scale and live fire demonstrations that you can evaluate, grade, and go back and discuss which one's best for your organization without the pressure of sales or any of that. So these performance metrics are tied to physical properties of the image and test conditions that are additional significance to firefighters and other first responders that facilitate their acceptance into practical use. That is NIST words, not mine, from a research paper called Technical Note 1499. You need to look that one up, because that is the research paper that helped build NFPA 1801. And it's a brain dump, but it's worth your time. And we're going to give you lots of resources through this webinar, and we're going to start with this. The other NFPA standard I highly recommend all training officers, fire chiefs, and people who make decisions familiarize themselves with is NFPA 1408, which is the only training program standard for thermal imaging per NFPA. So it says all participants shall understand the functions, modes, use, accessories, specifics to their TI being used. Well, there's a lot more in there than just that. And when you read it, you'll realize, wow, we're not doing certain things. We don't have policies. We don't do annual training. We don't do training before these things are placed into service. So let's understand what's required of us and use these free resources that we provided along with others. Like here's one explaining dual gain temperature modes, mixed gain temperature modes, and tri-gain temperature modes. You're like, why would you put that in there? Because NFPA doesn't really explain that other than high and low sensitivity. So we want to give you the resources so you can understand it in a 3 to 5 minute explanation versus trying to read a 100-page dry document. So let's talk about where we're at. I travel a lot and I'm blessed to meet a lot of great people. I get a lot of phone calls every day, and you wouldn't believe what I hear and see when it comes to, hey, we need to look for parts for this 1999 thermal imaging camera. I'm like, which model do you have? One the other day was a K90 Talisman. A Talisman is a BST, brondium strontium titanate detector. Not even in production, can't buy parts for it. It looks like a yellow submarine on a stick. That would be like asking you to get your old smartphone, not so smartphone out of the drawer, your Nokia here, and try to play Facebook, emojis, or trade stocks on it. It's not going to work. So don't expect your older thermal imaging camera to perform like a newer iPhone or Android. This is from a fellow instructor, John Lightly, who came up with this, which I thought was pretty smart. Firefighters have multi-million-dollar fire trucks, multi-million-dollar fire stations, but I see 20-year-old or older thermal imaging cameras still on modern fire trucks. And if you're old enough to remember the Atari game Pong, that's what a person looks like on some of these devices. So please, let's update our technology along with our training, because this is just a few of those cameras that I've seen in the last 6 months in traveling. A Bullard MX, Scott Eagle 160 or 320, the K90 Talisman, which I just told you about. I have 2 of these in my little antique collection. MSA 5000, that's what my department had for about 15 years before we upgraded in 2018. And the ISG XLR, that's probably one of the more common ones I see. If it's older than 2013, ladies and gentlemen, you need to replace it. And here's why. 2013 was when the first NFPA standard was for 1801 was introduced. Then there's the 2018 standard. Now we're at the 2021 standard. That is the standard that tells you how these cameras should be built, tested, resolution, interoperability, durability, intrinsic safety, all that stuff's listed in there. And anything older than that doesn't follow those standards or performance metrics. So you don't know what you're getting, and you're definitely not getting the image quality that you could be getting in a newer model. So I would ask you, which image do you prefer? The picture on the top is a Scott Eagle Attack, and then the picture on the bottom happens to be from a FLIR K65. Those cameras are over 10 years in difference in production. There's a big difference every year in a cell phone, a TV, and everything they do when they update the technology. Don't you want to give your citizens, their property owners, and your fellow firefighters the best information possible in the quickest, fastest, easiest way without them trying to judge what shadows, blobs, and spots looks like on older cameras that are out of date and that do not respond or keep up with the challenges of today's environment? So here's why this is even more important. This happened last week. I had a firefighter ask me if he could buy a TG-165 for a situational awareness camera. And a TG-165 by FLIR is an automotive inspection camera. It looks just like a K1, but it is not fire rated. I had a department buy 5 of these and take them in a fire, and they all quit working. You think the manufacturer is going to honor the warranty if we buy an industrial camera that's not designed for firefighting use and take it in a fire and they fail? And the response I usually get is a tick's tick. No, it's not. There's thousands of models of thermal imaging cameras for various contexts and uses. Fire service cameras are completely different than every other camera on the market because they're built for a very unfriendly environment. Keep that in mind as you look through these devices that we talk about today. And the thing that I want you to think about when you go through this, some more NIST quotes for you, is we want you to be able to interpret the data fast, quickly, easily, successfully, and you should be able to operate these devices with a gloved hand. I just recently attended an industrial fire conference, and I asked them if they could operate their industrial cameras with oven mitts on, to quote my friend Robert Ramirez. I love that line from his Mayday Mindset presentation. Could you operate a highly technical device with oven mitts on? No. These cameras should be able to be operated with a gloved hand, and they should be able to display that image and data quickly, fast, and it should be easy to understand. Not complicated, not fancy icons or color palettes that firefighters are not trained on. That's why NFPA 1801 is very important for you to understand, because it also talks about the recommended color palette that you should use. So let's talk about where we're at and where we need to go. We have two types of cameras being marketed to firefighters today. The camera we want you to test and evaluate is none of these. These are situational awareness cameras, and they're great for their intended context, but they're designed to prevent firefighter disorientation. Decision-making cameras have higher resolution, better interoperability, better durability, and they have a lot more things they go through than a situational awareness camera has. The ones on the left of this image are 9 hertz or slower. The ones on the right, the Seek Thermal device, the MSA iTick, or the MSA Lunar, are between 16 and 30 hertz refresh rate. You don't want a device that's at 9 hertz to be used for situational awareness. 40% of America doesn't know the difference between a situational awareness camera and a decision-making camera. And I get emails proving that every day. They buy the cheapest thing they can and put it in everybody's hands thinking that's good enough. I challenge you to watch the webinar from this QR code at the bottom that we did with Seek Thermal that tells you the difference of these two models, why they're both important, but they should be used in their proper context. Now, Seek Thermal's pushing the boundaries of that with the FirePro 300 because it gives you a decision-making camera inside of a situational awareness housing. However, it is not quite as tough as that Attack Pro. You have to make sure that you are testing these cameras to see the difference, because this Attack Pro here in this image is a decision-making camera. So we're going to start with step 1 of our process, which is you need to choose 3 decision-making cameras for your department to test. And you say, why 3? I've had departments ask for 4, 5, 6. It gets very confusing if you get outside of 3. If you do your homework, you'll figure out there's only 3 or 4 that you'll want to look at. And when you narrow that down, then you test those top 3 based on this criteria. They need to be higher resolution, a minimum 320 by 240. They need to have at least a 25 hertz refresh rate or frame rate. They're used for strategic decision making. In other words, they're in the company officer or designated adult's hands. They need to have interoperability, which means the green buttons, the power button, the symbols are all the same based on what NFPA states. And they have to be extremely durable. You got to build them like a tank. And they have to have a larger display so people can see them better. If you'd like to learn about those, differences in decision-making cameras, you can scan that QR code there. Notice I've got resources in through this. I think I've got about 20 hours worth of videos in this 160-minute presentation for you to use. And here's your breakdown of that criterion. If we're going to pick out these 3 cameras, I have 3 cameras here for you to look at. I have a Seek Attack Pro, a Bullard NXT, and a FLIR K65, all exceptional cameras. We need to grade them by their field of view, their temperature modes, how they see that environment when it's cold or when it's hot, the resolution, how sensitive they are to smaller details and temperatures or thermal sensitivity, refresh rate, and what can I detect? Can I see something 20 feet down a hallway, 30 feet down a hallway? How far can I see something in a fire? Not in a day room, not an ambient temperature environment. And these 3 are all excellent cameras, but you need to test them to see how they're going to perform. And more importantly, will your firefighters even carry it? Because I hate to break it to people. Firefighters are finicky. If they don't like the way it feels, they won't carry it no matter how great it is. Here are some examples of some decision-making cameras for you to look at. Currently, these are on the market that you can look at. They're the Argus Mytix series. Bullard has the TXS, QXT, or NXT. Draeger has the Fire Vista. You have the FLIR models that are K53 through 65, 53, 55, 65. They do have some models that are lower than that, but their resolution doesn't meet the 320 by 240 standard. Leader has the 4.1 and 4.3. MSA has the 6000. Seek has the Attack Pro, Attack Pro Plus, and other models are coming. Not just replacements of stuff that's old and outdated and needs to be replaced, but there is a Chinese contingent coming to the market, and they will be in the US. I don't think they're going to be able to stop that. So they're going to be newer cameras that we've probably never seen before in the next 2 years showing up on the market. So make sure you do your homework, because I'm not at liberty to say any of those things or know all of those details. So you need to be well informed of what's coming. Let's talk about the next step. We've decided on decision-making cameras. We picked our top 3. Now, let's look at the performance specifications of each device. Let's lay them out on paper. Let's look at all the specs that the manufacturer says, and let's compare them. Field of view, let's look at resolution, and let's not, if we have 3 of them that are all 320 by 240, what sets them apart? Are the pixels smaller on one? Is one 12 micron, another 17 micron, another 25 micron? That makes a difference. And let's compare how they process that image as far as when they look at the heat. Is it a high and low sensitivity? Is it a mixed gain? Is it a tri gain where it splits it into 3 ranges or spans? And let's look at the color temperature correlations. When does your camera that you're grading show color? Does it show it in high sensitivity and low sensitivity? Does it show it only in low sensitivity? When does it kick in? At 200 degrees, 300 degrees, 500 degrees, 1,000 degrees? All that matters. And people are not looking at that. They need to look at it. And believe it or not, you need to look at how long the battery life lasts, because whatever they say it's going to last, you might as well cut that in half, because firefighters are going to mess that up. We are going to treat this device badly, and it will perform poorly and then we'll blame it because we didn't take care of it. And then what's the warranty, and who is going to provide you service when you break it? I haven't met one department, including my own, that didn't break these devices, because we're hard on things. We're hockey players, not ballerinas. And to make life a little easier, I broke down a few of these more popular models right here to give you an example of what that looks like. If I'm going to compare the specs, I need to know them. And rather than have instruction manual, how about we have a simple graph? Here's an MSA 6000, FLIR K65, Bullard NXT, and Attack Pro Plus. These are all NFPA compliant models. We have the field of view, the resolution, the thermal sensitivity, the refresh rate, and whether or not it's NFPA compliant or not. That helps us a lot. Those of you who are asking yourselves, why does he mention NFPA compliance? If you are using AFG money, Assistance to Firefighter Grant money, you have to buy NFPA 1801 2021 certified models, period. Can't buy anything else. You have to buy the current NFPA certification. If you use it outside of that, I wish you the best. I have an article on my website on how to do that, the standard, where you read it in the FEMA document, and you can have that grant amended to include training if you so wish. Let's go through 3 of those cameras that I listed for you. Seek was kind enough to sponsor the webinar, so we'll start with theirs. They have an Attack Pro, an Attack Pro Plus. One of those is NFPA certified. That would be the Plus. This is the entire instruction manual in one slide, and the attributes that I listed that you should consider. You have the Attack Pro webinar on your right, and the Attack Pro Plus webinar on the left, which talks about the value of NFPA 1801. I'm a big fan of that particular standard. That's the first one. Then we have the Bullard NXT or QXT. The NXT is the NFPA compliant model. Notice I also have a Bullard overview webinar you can review that I posted on my YouTube channel. And it tells you the dynamic range or temperature range of the camera, the field of view, how it sees the heat. In this case, it does it in high and low sensitivity. When you see low sensitivity in a standard camera, there will be a green triangle that shows up in the upper left-hand corner, which you see in this image. All 3 of the models that I'm going to mention to you today all use image enhancement, which makes the picture look better. Seek uses SV1, Bullard uses X Factor or ICE, depending on what you read. This is a fast camera, 60 Hertz, and the distance to spot ratio is how far away this camera was calibrated at a perfect black body in an air-conditioned warehouse, which was 57 feet to measure a 1 foot square. And it's one of the more insulated, better durable cameras on the market. And as a lot of them do, they offer a pretty cool feature called thermal throttle, which is an investigative mode. If you have noticed, I've been posting a lot of things on the power of investigation mode color palettes to help you find problems. And then we have the FLIR K55 or 65. The 65 is an NFPA compliant camera. The 55 is not. If you notice, when you pick this camera up and look at a 55 and a 65, the only difference other than the sticker is the battery on the bottom has a locking screw on the 65. That's what they call it, non-incentive or intrinsically safe. We've also included a free FLIR overview webinar there for you to review that one. So now I've given you 3 cameras, broken them down so you can use them for later and review them. We're trying to do your homework, help you out here so that you can go through this with your organization and check these devices out. Now we're at the fun part. We picked our 3 cameras. We know the specs. We know kind of the pros and cons. We know how much money we're going to spend on them if we buy them. We know which vendors we kind of like. Now we need to burn with them. How do we do that? Well, we do it 2 ways. We use a small scale live fire prop like the Max Firebox, where everybody can stand outside with no mask or air packs on and ask questions and take their time and do the things that we'll show you. And then after that, they grade them that first time. Then we take that same crew and we put them in full turnout gear and take them into a Class A burn facility and let them look at heat in low, moderate, high heat. We give them some targets to look at. We put a shiny piece of metal in there to do an emissivity demonstration to see how reflections look. And we do all of that so they can compare those cameras. And we have a clipboard laying outside that has the chart for Bullard, FLIR, Seek, whichever you're evaluating, and you grade them 1 through 5, 1 being poor, 5 being awesome. And at the end, you go back in the classroom and you add up that and you discuss what's best for your department. Not me, not the salesperson, not the manufacturer. Your department's purchasing these or you're buying this on your own. You should be the one having the final say so in that. So let's talk about how we don't test them. First of all, if you don't have training in thermal imaging, you shouldn't be testing them because you don't know what we're looking at. So let's learn those criteria and how we evaluate. We shouldn't perform an evaluation on a camera unless it's been turned on, fully powered up for 30 seconds. Because if you haven't done that, you'll experience the camera goes through something called flat field correction. It freezes, it clicks, it makes noises. It's calibrating itself. And we do not evaluate anything based on spot temperature differences. We'll discuss, if you noticed in the seat picture here, why that number is not there. NFPA has removed it for a lot of reasons, very good reasons. And we do not evaluate performance of thermal imaging cameras in ambient temperature environments. Let me say that again. You never buy a camera based on what it looks like in a 72-degree room, because that's not the work area that you work as a firefighter. And we do not evaluate performance standing up or failing to wipe the lens of the camera. You would not believe the number of incidents that I review each year where firefighters have maydays, injuries, and unfortunately worse, where they did not wipe the lens of the camera, the image degraded, and they considered the camera had whited out or washed out the image when they were simply standing up, didn't get down and didn't wipe the lens, didn't know that would help improve the image clarity. We do not vary the testing parameters. We have one set of parameters and we test all 3 cameras on it to have a control, and we make sure we stick to that. And we do not evaluate performance of cameras in artificial smoke environments. Do not do that. It is a thermal imaging camera. It needs thermal, it needs heat. We need low, moderate, and high heat. When I said we're going to talk about why there is no spot temperature, despite all the manufacturer's user warnings, and thermographers know this, firefighters continue to misuse this number, and it was listed as a contributing factor in 3 line of duty deaths. 3 incidents where firefighters died. And I've seen it as a contributing factor in rekindles, that firefighters have used this number inappropriately and came back later only to find out that number wasn't right. If you'd like to learn more about that, our most read article that we've had on our website for years is the danger of the spot temperature. And it talks about the maydays, the line of duty deaths. It gives you a chart and tells you how it's several hundred degrees off in certain environments. And people think we've been preaching spot temperature use. We don't. We have been telling people this is a qualitative device and you use the numbers as a diagnostic tool, not as an exact measurement. Make sure you understand that. There is a big difference between qualitative thermography and quantitative. Quantitative is industrial. They're looking for specific measurements. Qualitative is not. We're looking for what's wrong, and we're looking for heat, layout, diagnostic, details, information, victims, things of that nature. And here's why you would want to consider that. These are some cameras on the market right now, straight out of the box. This is how far they're off. The Seek's off by plus or minus 5 degrees. The FLIR's off by 7.2 degrees. The Bullard's off by plus or minus 5 degrees. The MSA is off by 18 degrees. Leader's off by 32 degrees. And the FLIR K1's off by 41 degrees straight out of the box. Now, do you think we should have these cameras calibrated when they're already off by that much? They are not designed to give exact measurements. They see in hundreds of degrees, not in single digits or tens of degrees difference. Make sure we understand that. So let's look at how we're going to grade them. When you take them into the fire, we would want you to do different variations of these objectives. Field of view, you're going to stand and then kneel. And you're going to try them in the standard pistol grip. You're going to try it in what we call the gangster grip, flipping it sideways, and see how much you can see with each camera in a cold, hot, and then hotter environment. So we say cold would be 200 degrees or so. We want to look at the difference of the camera in high sensitivity or low sensitivity. If you're using the Seek, it has mixed gain modes. You don't have to worry about that, but you can see how it goes from the cold area to the hot area when you scan from the floor to the ceiling and see what happens. And we want to grade the resolution at preset distances. We want to look at differences of looking at a target down a hallway versus as we get closer to the target and right on top of the target. How good can you see that target, whether it's a mannequin whether if you place a fire helmet or a boot or whatever you use, you need to have something that all three of those cameras look at. And that little QR code goes straight to our website on this entire evaluation lesson plan on how you do this. Please make sure you use it. We want to grade the emissivity demonstration. All of your fire service cameras are preset at either 0.95 or 0.97 emissivity, which is the ability of an object to emit, absorb, or reflect heat numerically between 0 and 1. And you're like, well, what is that? If it's shiny, it's going to be off. If it's more of a matte surface, it's going to emit or absorb or transmit energy better, and the camera will pick it up more accurately. Still not exact. But what we do is we put a shiny surface near that fire room so you can see what a reflection looks like in a bullet or FLIR or seat, so you can compare it. The downside of really good cameras is reflections also look really good, sometimes too good. Then we're going to test the minimal resolvable temperature difference of the camera. We're going to see how fine of a difference we can see in small objects that are similar temperature laying in a fire room or near a fire room. So if we place a mannequin right next to a pile of clothes, or we place two objects and we want to see, can I tell the difference between those two objects when it's colder, warmer, or hotter? And probably the most difficult thing we get firefighters to do is grade the grayscale and the colorization. I think it's funny because gray is a color, but you need to be able to evaluate how well does it show convection currents, thermal layer, and then when does it show color? Does it show too much color, not enough color? Does the color block out details? Does it allow you to see details within it? NFPA 1801 says that details shall be resolvable within colorization up to the point of saturation, which is a fancy way of saying you should be able to see through the color up to the maximum temperature range of the camera. Then it just blocks out any detail whatsoever. Some do, some don't. You won't know until you test it in a fire, like my friends from LA County here did when we were training with them. And when we test the field of view of the camera, we need to know, one, what the minimum is, and that the wider the field of view, the better our chances of seeing that room. NFPA says the minimum should be 20 by 36. The first number is vertical, the second number is horizontal. I wouldn't want a 20 by 36. I want a minimum of 38 by 50 and up, because that's what I've been using for years. And I can tell you that's way better than when you go in these real narrow ones. The real narrow ones are great when you're on top of something close, but when you're trying to see a big room, open floor plan, or warehouse, those aren't so great. So you want to make sure you have a wider field of view so you can see more of the threat, more of the area for your diagnostic purposes for live fire and layout. And the importance of field of view is stated by NIST, telling you that you may rely on this to navigate through a burning structure. Therefore, most cameras need a wide field of view. This is what NIST says, between 40 degrees vertically to 60 degrees horizontally. Now, NIST doesn't have a dog in the fight, and they're telling you you need a wide field of view. And they're also telling you that while temperature measurements may be useful, the accuracy of that measurement is not as critical as people might think, or in other thermal imaging applications, which would be your industrial applications. So we don't need to know exact measurements as much as we need to be able to see how much we can see and how well that image is displayed based on that camera and its algorithms and the software it uses. Then, oops, hit the wrong button, sorry, going forward. When we look at field of view comparisons, here are the models I've mentioned along with a couple others. You can see that they vary. The Attack Pro and Attack Pro Plus is 42 by 57, which is currently the widest field of view on the market. Leader is 40 by 51. The Bullard TXS is 40 by 50. FLIR is 38 by 51. Argus is 37 by 50. And Bullard is more narrow but very detailed at 31 by 40. You need to know that up front, that they are not the same. You're looking at telephoto versus wide angle lens. If you're into photography, you know there's a big difference in those lenses and how they perform. And then when we look at the three that I mentioned that I showed you images of, you can test them in your pistol grip style or flashlight style, and you can hold them one way and then turn them sideways to see how much of the image can you see. Can you see the floor and the ceiling in one view? Why is that important to you? Does that help you, hinder you? Do your firefighters like the pistol grip style, the flashlight style? Because firefighters don't like change. So if they've been using, for example, a flashlight style camera for a while and you go to a pistol grip, they may rebel. Make sure that you are testing these out with the people that are going to use them. No offense to our command staff, but if you take the command staff in to evaluate cameras and the command staff aren't going to be carrying the cameras, you've made a huge mistake. You need to let the operations personnel who are going to use it give their feedback and then make the decision, and don't disregard their feedback. Let me say that again. Fire chiefs, purchasing agents, logistics, people who make the decisions, you need to listen to your firefighters. If you don't, you're making a huge mistake, because the end user is the most important opinion. And those cameras, when you evaluate what we call the temperature modes, you need to understand that temperature modes are automatic. The camera automatically changes between high and low gain or high and low sensitivity based on its programming. But some of them have selectable application modes, such as FLIR has a search and rescue mode. Bullard has a electronic thermal throttle. If you looked at the Seek Fire Pro 300, it has a survey mode. Those are application modes for different environments, typically lower temperatures. Make sure you know what those contexts are for, but we're not grading those as much as we are grading what the fire service tick does in a fire. What does it do when seconds count? Yes, there's lots of cool features, and I like them, don't get me wrong, but I need to know when I turn it on and go into a fire, what is the basic functionality of the camera going to do? And how are my operations in service firefighters going to respond to that and use that? And can they interpret it quickly, easily, and not be confused by it? And this is every fire service camera on the market in one slide. They work either in single gain, dual gain, tri-gain, or mixed gain. Now, this is currently, cannot predict what is coming, but currently you either have cameras that see one temperature range, or they see a temperature range split into two spans, which is dual gain. Most cameras operate in high and low sensitivity, hence why you would see the green triangle that started around 2012. And then you have some older ones, like we talked about, antiquated, that had a blue L for the low sensitivity indicator, or an EI, which stood for electronic integration. Some of them just simply said hot. And then you had tri-gain, where they split the temperature range into three spans, such as the old Scott X380. Leader does it, Argus does it, and a few other cameras that we don't have listed here do. And then you have mixed gain, which is offered by Seek Thermal, which is each pixel switches independently on its own. You don't have to worry about worrying about an icon showing up. And rather than go through every camera on the market, we're going to play a short little video and show you those cameras and what they do. We're going to start with MSA. We're going to look up, and we're going to go from high sensitivity to, whoa, low sensitivity. Where'd my color go? Because it won't show color again until when? 1,000 degrees. That's pretty grayscale, but that's counterintuitive to me. Now here's the Bullard looking up at the ceiling. Heat's moving across. It's in low sensitivity. We're going to make this camera go back to high sensitivity by dropping the camera down. This Bullard has an extremely impressive image. Notice the clarity here is really good in high sensitivity. So their camera is really good in high, and low sensitivity, the image diminishes. You look at FLIR, you notice that when we went from high sensitivity, the picture was okay. Low sensitivity, the picture is really good. You notice here there is a delay when it's switching. Then we're going to watch the Seek Attack Pro with my friends in Germany doing some search evolutions like American firefighters. Notice there is no delay. There's heat behind them, but you can still focus in on them. And I don't have to worry about icons. You can watch example after example of any camera you want on my YouTube channel. You pick the playlist and say, I want to watch Bullard. I want to watch FLIR. Then you can kind of have an idea before you go do your testing and know, hey, it's going to look like this. I've seen enough of these videos, listened to that bald guy from North Carolina enough. I know what this is going to look like. And I want you to have that. It's free. Okay. And this is a few of those cameras side by side telling you what it takes for each one to switch to low sensitivity. As we talked about with Seek, it only takes one pixel. Each pixel switches independently between high and low gain or high and low sensitivity on its own. FLIR takes 2% of the overall pixels, which is 1,536 pixels if you do the math. Bullard takes 3%, but they do it at 230 degrees, not at 302 degrees. So that's a lot more sensitive. They do it in 0.3 of a second. Leader does it at 5% of 110,000 pixels because they have a bigger detector. So that means 5,509 pixels have to be in agreement before it switches. And MSA requires 32% of the pixels to be at 290 degrees Fahrenheit before it switches. So that's a lot. So this is your chart showing you how much each one takes to switch to show higher heat in low sensitivity. And if you read that dreaded training document I talked about earlier, NFPA 1408 also says that we shall be able to interpret the colors displayed and the associated temperatures and temperature ranges with it. Why is that important? Because I visited fire departments that would have 3 different brands of cameras all in operation in the same fire department, same fire ground, and those 3 cameras showing that fire 3 different ways. That's not good. We want uniform hose loads. We want uniform cameras. You don't wear mismatched turnout gear. We don't need mismatched cameras. It causes confusion with firefighters. Teach them something they can understand and let them stick with it. And then every 5 years or so, you're going to have to replace these cameras. That's just a fact of life. Everybody who gets a new iPhone every year, they have a fit when they want to buy a new thermal imaging camera every 5 to 10 years. This is the Attack Pro color palette. 0 to 301 degrees is black, gray, white. And then at 302, you get yellow. 575, you get orange. And red, you get 850. What this one does differently is you notice that the firefighter in the hallway is still visible with all the heat that's visible inside of this fire room. That's because of mixed gain mode. The pixels that are in the fire room are in low gain. The pixels where he is are in high gain. And it does it simultaneously, automatically, without using any icons or fancy buttons or anything like that. Turn it on, go to work. That's their color palette. And many cameras on the market show color early. So I'm going to show you two cameras that both show color at 302 degrees Fahrenheit or 150 degrees Celsius, depending on where you are in the work. So we have a FLIR and a SEEK looking down the same stairwell. The fire's at the bottom. By the way, this is not a good place to stand. Our unofficial motto is we used to do a lot of dumb things in the name of science. You look down the stairs, you can see the convection currents coming up the stairs, but you notice one is showing color and one isn't. They both require, or both will show color at 302 degrees. The difference is the sensitivity. Mixed gain mode in the SEEK is going to show it pixel by pixel, where FLIR is going to take 2% of the pixels before it switches. Both are excellent cameras, but you need to know, just because you don't see color doesn't mean it's not hot. The absence of color is not the absence of heat. The gray, white moving stuff is convection. You don't believe in that? See these fancy convection ovens? We got one on our little countertop. They cook your food twice as fast for a reason. They're circulating heated air. And that's also what they use to test a lot of our fire equipment in a forced air oven test per NFPA 71. And you want to see how this camera performs when we're walking around a building. This is a great test when you're done doing all your interior testing of the building. If the building's still hot, have your firefighters walk around the outside of the building when you're done and just do size up with all three of your cameras and compare them, because now you've already seen the small scale test, you've seen the interior test, and now you can see, what does this thing pick up if I'm looking at a shipping container, I'm looking at a wood prop, or wherever I am. In this particular example, this is a well-involved structure fire, and you can see as he's walking around the heat emanating from the first and second floors. And if you watch really closely, you can actually pick up on something pretty amazing right there, which is a single pane glass basement window well. There's fire in the basement, or either the floors collapsed, we don't know, but we have heat coming through that window because single pane glass does not stop infrared energy. The whole thermal imaging cameras don't see through glass thing, it's context, ladies and gentlemen. You don't put single pane windows in newer homes today because our money would literally go out the window. That's why we have double pane, triple pane for insulated purposes. So when you study thermography, you start to learn that heat transfer is always occurring. You can't stop it, but engineers try to do something, basically prevent something called thermal bridging, energy being lost from the interior home to the exterior home. Here, we have energy being lost, and it's to our advantage so we can see it. That's a great way for you to grade the camera after you're done. And then when we talk about grading refresh rate, one of the things I like to do is take the camera and have something in the floor and try to point at the coldest area and then turn and look at the hottest area and see if the camera freezes, lags, or delays information, just like this. So as you can see, when we were scanning around, we had very little lag or delay. Many cameras will shutter, most of them will shutter at some point when you're looking in a hot environment. On average, the average fire service camera, if it's really hot, every 30 seconds, you may see the screen freeze because it has to refresh those pixels so it doesn't burn them up. If it's cold and sitting there just laying on the counter, every 2.5 minutes, you may see the screen freeze or click. That's a standard operating procedure of many cameras. Now, if it's freezing when it's going between high and low sensitivity, that is the gain change, and you need to grade that on how fast that occurs, and do your firefighters understand that? And when we talk about thermal sensitivity, please make sure you do read the specifications in the instruction manual. I've found more errors in instruction manuals than I care to mention, and noise equivalent temperature differential, or NETD, and MRTD are used interchangeably between manufacturers, and they're not the same thing. I've reached out to all the experts to get firm definitions and explanations on these things to make sure that I'm not steering you down a wrong path. But NETD is the ability of a camera to detect temperature differences between two objects. That's what the camera can detect. MRTD is what defined by the military is what your human eye can detect. So yeah, the camera may be pretty sensitive, but my bad eyesight might not be able to see it. ITC, MovieTherm, Seek Thermal, Insight, several other people have all looked at this. And one of the things you need to realize is a lot of these testings are not done in the same environment. Some of them do them at 50 degrees Celsius, some of them do it at 30 degrees Celsius. That matters because a lot of the number ratings you see are done in high sensitivity only and not low sensitivity. So what are those ratings and how does that affect you when you look at those devices? Make sure you understand that and try that out. Does a victim in the floor look really good in high sensitivity, but don't look really good in low sensitivity? Don't you think your firefighters might need to know that? And believe it or not, one of the most important things you can grade back in the classroom after you're done burning is simplicity and ergonomics. Will they be able to carry it? Is it too heavy? Is it easy to operate with a gloved hand? And I mean, is this thing going to cause them unnecessary problems because it's too difficult to operate, too difficult to carry? Another NIST quote in here is the urgency of a fire event also dictates the need to keep the operation of the imager as simple as possible. Simple as possible. You should be able to operate it with a gloved hand, hold it out at an arm's length, and be able to see that screen. If you can't, it's probably not the camera for you or your department. And when we talk about ergonomics and ease of use, there are different types of styles. There's pistol grip, there's flashlight style, and then you have these ones like this one where you have to slide your hand on either side. Leader makes it this way, Drager's Fire Vista's this way. You need to try those out. Your fire department may not like certain styles. And in the end, the committee's got to make the decision based on what the fire department thinks they would like. If the committee likes it, and the committee's the A+ top performers, but you got 80% of the fire department who's going to prefer one style, you're going to make sure you consider the needs of everybody in your fire department. How heavy is it? Is the screen big enough for you to see? The button's got to be operated with gloved hand. The button should be green in color. And the functionality, if it has all kind of other buttons on it, if you can't operate with a gloved hand, the buttons don't matter. So make sure you understand how that works and know that a lot of extra buttons can sometimes lead to extra problems if they're not well trained in. Okay. We've included some little comparisons you can do when you're back in the classroom. You need to have these things already spec'd out. Hey, here's the MSA. It weighs 2.68 pounds. It's 11.6 inches tall by 7 inches wide, and it's a pistol grip orientation. Here's the Bullard. It's 2.44 pounds. It's flashlight style. It's got an integrated battery, where the other one's got a detachable battery. Got the measurement there. We got the FLIR. We got all those things you need to list so that they can compare those side by side. Okay. We want you to have that data so that you make a good decision. And the other thing that a lot of people never look at is this, the front of the camera, the germanium window or whatever type of window it's using. This is where the energy goes through. Is this easy to wipe with a gloved hand? Okay. Only 2 manufacturers have redundant windows. Bullard and Seek, both, if you break that germanium window, they have another lens behind it so the camera will still function. MSA and Argus, you can actually change those lenses out back at the fire station. The rest of them, you got to send them back to the manufacturer. Do you know how this works? Do you know how to tell your firefighters to take care of them? Don't clean them with a grill brush, right? Soap and water and alcohol wipes. And do they know to wipe this lens periodically in the fire environment, or else the image will degrade? How easy is it to wipe the lens? How fast does it fog up? You need to test that. And then when we talk about batteries, some of these have batteries that are integrated like the Bullard. Then the rest of them are removable. Are they easy to remove? Are they difficult to remove? That might be a pain. How long is the battery life versus the battery warranty? If I were you, I'd spend more money on batteries and extended warranty than I would anything, because firefighters mess that up and we're going to break it. I'm not a big fan of spending a lot of money on truck chargers because that's an extra piece of plastic and it's usually mounted on top of the hottest part of the fire truck, which causes problems with the batteries, because batteries don't charge above 104 to 112 degrees. You're working in Houston, Texas. Tell me a day that they don't have 104 degrees inside of that fire truck. That's really hard on a camera with lithium ion batteries. So make sure that you invest well and do your homework on how these things work. And then what device am I buying compared to when it was made? So if I look at the production dates of all these cameras, odds are some of these are about due for replacement. So you're buying a new to you camera that may be 10 years old per the original manufacture date. So make sure you understand that, even though it may be new out of the box, it's not new when it was made. It was originally made in 2013 or 2014 or 2016. On average, your NFPA certification changes about every 5 years. So you're probably going to see changes in cameras about every 5 years, and sometimes faster, depending on if it's a situational awareness camera versus a decision-making camera. But this is all data that you need to consider when you're looking at these devices. And just please make sure you do your homework. Please make sure you spec these and test them and understand that they're not just standard infrared cameras anymore. They have all kind of other things added to them. A standard infrared image is not impressive. An infrared image with all the enhancements is an impressive image. Seek, Bullard, and FLIR, actually Argus has it too, called the Ignis engine, have image enhancement software to make the picture look prettier. And it is prettier. Then you have additional features like Bullard has the electronic thermal throttle. Argus and Scott have a hot spot, cold spot tracker. Then when you look at it investigative modes where you're more of a low temperature color correlation, I'm trying to find hot spots in overhaul or size up or smells and bells or odors of smoke, Argus, Bullard, FLIR, and Seek all offer that. So is that something your department's interested in? Is this strictly a fireground camera? Or is this going to be a fireground, hazmat, lost person, multi-purpose all hazards camera? If it is, it might need more features. And by the way, that means you need a lot more training. Okay. And if you want to make your life easier, ladies and gentlemen, the two most important webinars I've done so far, in my opinion, is this one and this one right here, Thermal Imaging Tips for Success. It basically talks about basic behaviors to make you successful when you're using. Please watch that one before you do your testing, because it explains how we fail and how we can succeed if we just overcome these basic behaviors when we're using the device. And then we've also included this. I've never done this before. This is a special Google Drive folder that I've been building. I started sharing it a while back. It has every resource that I can give away for free for Bullard, for Argus, for FLIR, for Seek. It has stuff on drones. It has stuff on fire videos. I'm just going to warn you, you can't open it with a free Gmail account. When you scan this and I get my phone blows up and says, so-and-so wants permission to access it. If I give you access to it, you don't have a $99 paid Google Drive, you're only going to see 4 or 5 folders, because there is a ton of information in there done by my cadre and a lot of other people. Please make sure you use this information to help your organization. The PowerPoint from this presentation and every other presentation I've done for Seek Thermal is in there. Every one of them. The NFPA one, all of them in there for you to use to help your organization. And you're like, why are you doing that? Why would you don't worry about people stealing your PowerPoint? I'm 48 years old and retired and run a very successful thermal imaging company. You know what I'm scared of more than anything? I'm scared of firefighters dying with these things in their hands or not knowing how to use them. My mission is to get you home safe. You can't do that if you don't know how to grade and evaluate these things and then learn how to use them. You don't have to use us for training, but you need to do your homework and be intelligently aggressive and understand how they can help you find the victim, find the fire, find your fellow firefighters, and get home to your family. That's our mission. This is our contact information. We're on social media. We post 2 to 3 times a day, every day, 7 days a week. My instructors have their own page. My lead instructors are adding more pages right now. We have Joey Baxa, Tim Mills, Thomas Anderson have their own page. It's through Insight Training. We have the Insight Fire Training page. Unfortunately, we lost our Insight Training LLC page last May due to the joys of hackers and Facebook. We have 2 Twitter accounts. We have an Insight Instagram page. We have a YouTube channel, which is probably our most used one. There's over 400 videos there, categorized by playlist, which most of these QR codes go to. Seek Thermal has also produced videos in partnership with us that goes to theirs as well. We're on TikTok. We're on LinkedIn. There's 2 accounts there, my personal name and company name. That is my email address and my phone number. I will gladly help you. I just want you to be successful. This webinar was done for one purpose. I want fire departments to take this seriously and stop listening to word of mouth and buying devices based on what XYZ department bought. Do your homework. Go test them. Have fun. Get in the fire. Play with them. That's what we signed up for, was go in the building. Get these devices and put them in the fire. That's what they were meant to do. And when you do that and you put them side by side, salesperson, the manufacturer, me doesn't have to tell you anything. The camera will sell itself to you, and you will figure out quite quickly which one is the best one for you. That's our goal. We hope you enjoyed this. We thank you for your time today. I'm right out of time. I want to make sure that if there's any questions, I can answer them. Brent, I'll give it back to you.
Yep, thank you very much, Andy. The number one question that I'm getting here is just where to find this webinar recording. And I think you mentioned it earlier, but there it is.
Yeah, you will. This is the resource folder, and once you give me a copy of the actual webinar recording to Brent, I will upload it to my YouTube channel, which they can pull that off of there, or this folder to be in 2 places.
Excellent. All right. Well, thanks everyone. Until next time, hope you guys have a great weekend, and you'll hear from us soon. Bye.
Thank you. Take care.